And now we're going to derive to prove the last formula from this set related to the parametric system. Okay, that's the area restricted by the given curve, and the curve is given not in a regular way, not as a function of y, function of x, but both coordinates are given as a functions of t, time. Okay, how to calculate area in these circumstances? Let's make up a picture. So that's the way, let's say, particle moves along this red curve. And we can always imagine x, y, and x-axis in light green here. And let's talk about particular area in some interval. So let's say we know already how to calculate this area under the curve using integration. That's what we have learned already in case of just regular xy coordinates. But now we are in the new circumstances, settings, parametric settings. Okay, so nevertheless, we're going to go standard way in calculus. In calculus 2, we're going to introduce a small piece of this area under the curve. And let's consider small change in x, delta x. Let's consider this bar. Okay, so the width of the bar is delta x, which is assumed to be infinitely small. What's the height? What's the height of the bar? It is equal to y, approximately equal to y, because the height is changing, as we can see here. But if we consider limit delta x approaching to 0, then intuitively, it's clear intuitively that we can use just one value to represent height of this rectangle, and it's equal to y. Well, the next question is, what is area of this bar? Area of this bar. It's a rectangle, approximately, but eventually it's a rectangle exactly, eventually, meaning delta x is approaching to 0. Okay, okay, so the area of rectangle is just product height times width of the rectangle. Well, so this is just approximation for the area of one bar, and then as it's supposed to be done in calculus 2, we're gonna add up all these bars under the red curve, and that is integration. The whole area is equal to integral out of this expression y times delta x. Well, now let's match the formula we need to prove with our current outcome. They're similar, and we can make them match even better by introducing delta t. We can divide and multiply by the same quantity or expression, dt in this case, and that's the match, not counting these absolute value signs. Let's ignore them for now. Okay, let's consider them later. But otherwise, we got it. So that's the formula. How to calculate area in parametric settings. That is how plug in y of t, which is usually given, then calculate derivative of x with respect to t, because x is given as a function of t, then calculate product and integrate along this particular interval in terms of parameter t, independent variable t. Okay, so basically and mostly we have derived the formula. So now let's talk about these absolute value signs. Absolute value signs, why they appear here. And that's another picture to consider. Example. So that's another curve. That's the way the particle moves along this red curve. We can imagine y and x-axis as well. And we can see, we can consider, as we already had such an experience. So this piece of the area under the curve is positive because it's above x-axis. But this piece, particularly this piece, let's make it yellow, it's negative. If we will be using this formula or the formula that we used before in the previous chapters, we remember, I hope we do remember, that the area might be negative. It's not possible, even possible in the real world, area cannot be negative, but it is possible in mathematics. It just means, it does mean that this area is located below x-axis, okay? So that's what it means basically. These absolute value signs, they are saying that if you are calculating area, so then be careful and then take absolute value of this value if it happened to be negative and you calculate area. Obviously you can take, we need to take the absolute value of this negative value, but that's not always the case. So this area, this formula might be a model for something different. For example, profit of a company, and then profit might be green positive, but it might be also negative easily. So that does make sense in this particular case. And then if you're working with such an application, then you may not need calculate absolute value out of this integral outcome. Okay, so this absolute value signs means take care of the sign. Be careful and be mindful about the application you are working with. And depending on the application, on the sense of what you are doing, it might be necessary to calculate absolute value out of negative. Or it may not be necessary, depends on the application. So now we have derived this formula completely, and we're done with all of them. All the formulas we need for this course are related to parametric system, parametric settings, circumstances.